Effect of concrete cover thickness and main reinforcement ratio on flexural behavior of RC beams strengthened by near surface mounted GFRP bars. This study aimed to investigate the effect of concrete cover thickness on the RC beams strengthened using a near surface mounted GFRP bars. Also, this study focused on the effect of main steel reinforcement on the efficiency of the GFRP strengthening bars. 9 beams were tested in bending to analyze the strengthening efficiency with different main steel and concrete cover thicknesses as shown in the table below. The reinforced concrete beams were designed according to the ACI codes. A load cell was mounted between the machine and the rigid beam to measure the load. Also, an LVDT was used to measure the deflection at the midspan. Strain gauges were mounted at the middle of the reinforcing steel and GFRP bars to measure the strains. Also, the data logger system was used to measure the data. A 3D finite element models have been conducted using ANSYS to analyze the strengthened beams, where the element size has been adapted to be 25 mm based on the mesh sensitivity. Solid 65 was used to model the concrete with the capability of cracking in tension and crushing in compression. Also, Link 180 was used to model the reinforcing steel and GFRP bars. And the Solid 45 was used to model the loading plates and the supports. Besides, Conta 174 was used to model the contact and the sliding between the surfaces. The results showed an improvement in the capacity of the beam with a 30 mm concrete cover thickness compared to the 50 mm one. But this improvement reduced by decreasing the near surface mounted GFRP bar length as shown in the figures below. As a conclusion, decreasing the concrete cover increased the flexure capacity of the strengthened beams, while this improvement reduced by decreasing the GFRP bar length. Also, increasing the concrete cover while decreasing the main steel reinforcement leads to higher strain induced in the near surface mounted bars. Also, strengthened beam with near surface mounted GFRP bar length extended outside the constant moment region showed a similar mode of failure, which is yielding of reinforcing steel followed by debonding and separation of the concrete cover.